Hello, everyone. Welcome to my talk at the Real-Time Analytics Summit by StarTree. Today, I'm going to be talking about event messaging and streaming with Apache Pulsar. My name is Mary Grygleski. I'm a streaming developer advocate at DataStax, and I'm very happy to be here at the summit. First of all, if you'd like to follow along, the slide deck can be accessed here on your screen here, and also with the QR code. Even if you miss it, don't worry about it, because the organizer will have this link as well. First of all, let me give you a 1-minute introduction of myself. Who is Mary? I'm a streaming developer advocate at DataStax. DataStax is a leading data management company that specializes in database as a service, NoSQL, big data, and now streaming, and also the cloud-native platform. Previously, I was with the Java and WebSphere open source advocacy team at IBM. I'm based out of Chicago, and I'm also a Java champion and president and executive board member of the Chicago Java Users Group. I'm also an active community builder of several other meetup groups in the Chicago area. I have an extensive lineup of experiences in product and application design, development, integration and deployment experiences, and I specialize in event-driven, reactive Java, open source, and cloud-enabled distributed systems. And here's a slide that describes what I do. And as you can see, these are just all the icons in here. And what I do, my interest is really into a lot of distributed systems and streaming platforms. And before we start, let's make sure everybody is on the same page. So I'll be doing some introduction to some conceptual kind of terms, namely event streaming, event processing, complex event processing, and event-driven versus message-driven messages. Then about event processing semantics, the Pulsar versus queuing. And then how can event streaming improve your systems? And what does it mean for analytics type of systems? Then I'll introduce you to Apache Pulsar, an open source library that's very powerful, a truly cloud-native event streaming platform. And also its dependencies on Apache Zookeeper and Apache Bookkeeper. And I'll highlight a couple of developer features for you as well. And then also, why Pulsar, right? So that's the goal of our talk today. First of all, let me talk about the many facets of computing events. There seems to be a lot of confusion, too, about what is an event. I was actually recently submitted my proposal to a conference, and the organizer came to me and said, "You mean event is like musical events?" Well, yes, it can be musical events too. But in the computing sense, though, what does it mean? So I looked up the Merriam-Webster.com dictionary website, and basically, first line summarizes whatever you're talking about. Event is just something that just happens, is an occurrence. And then in the fourth bullet point too, I really like that because it comes from the theory of relativity. So if you're a math person, you know that there's X, Y, Z coordinate. That's the coordinates of place. So essentially too, event is basically the fundamental entity of observed physical reality represented by a point designated by these three coordinates. And in the event case, it's even more interesting because it's bringing in the fourth dimension in the space-time continuum postulated by the theory of relativity. So that's time. So it makes kind of doing work in event-driven, event streaming, everything to do with events, much more challenging, but at the same time, also a lot of fun too. First, let's then talk about event streaming and processing. So it's essentially the practice of taking action on a series of these data points that originate from a system that continuously creates data. So again, event refers to each data point in the system. And the stream basically refers to the ongoing delivery of those events. And then a series of events can also be referred to as streaming data or data streams. So it has a lot of usages, especially in today's very rapidly changing and asynchronous processing world. Then let's kind of move on a bit then to complex event processing. So complex, when we brought up the word complex, it's basically it implies a set of techniques too, in this case, for not only like capturing and analyzing these streams of data as they arrive. And the purpose is to identify opportunities or threats in real time. So one really good cases of using event streaming would be in fraud detection system. And the really big advantage of using real-time processing system is that everything comes and you do the work right away. There's that real-time kind of attributes to this kind of processing. And it enables, right, complex event processing will enable systems and applications basically to respond to events, to trends and patterns in the data as they happen. For example, you don't want, your bank account, if it's not being monitored for any kind of fraud activities, then you would be losing money. So basically, fraud detection system can employ these techniques and basically monitoring the data as they come in. If there's any kind of unusual activities in your bank account, you'll be notified right away. So that's the power of using event streaming, this kind of capability to help. And now then, let's move on a bit then, back to a bit talking about messaging. So messaging too, there are essentially kind of two kinds, kind of broadly speaking. One is the event-driven way of doing things. And basically, it's about more like a pub-sub type of kind of approach in which the sender that produces the messages will emit the messages, and then it produces the messages, and then it's up to those who are interested in the messages will have to subscribe to the messages. So kind of it implies like this producer producing messages without worrying about who is going to be receiving the messages. You don't need to worry about the addresses of the receiver. So it's basically whoever is interested, then I have to subscribe to the messages, and then I will receive the messages when the messages gets produced. That's event-driven. And then there's also message-driven messaging. So that's more about point-to-point. It's basically the sender and the receiver will have to know each other. So basically, the address of the receiver will have to be known. And in this case, too, it can be bidirectional. You can have sender and receiver kind of talking to each other. They kind of know each other. So that's kind of the primary differences between like event-driven versus message-driven messaging. Now, then kind of take a look into like event approach versus batch processing. In the event world too, it's not anything very new. And in fact, a lot of telecommunications, in fact, they are already using event streaming, event kind of processing, except maybe their approaches were a bit kind of older, the time when it happened. For example, in the 70s, 80s, that's when this language, Erlang, that comes out. And Erlang, too, employs this technique is basically called the actor model, which to this day, right, there are also systems that are leveraging on this actor model that kind of guarantees messages won't be lost. And that's kind of the power of it. So that's event approach. However, you may be asking, too, if we don't use event approach, then what do we use? And that's when we can use batch processing. And batch processing is still highly relevant. In that case, too, batch is usually it's the time when you want to process like system of records. For example, you are in a company, you are using your employee system to update your employee record. You move and you need to update your address. So that kind of information is not urgent. So you can wait and you can batch up all of the changes. And then at the end of the day, when your system kind of being free up to do all of these batch processing, and that's when you want to gather up all of these less urgent things to kind of be processing all those things. So that's kind of like the differences between, what you can like use, versus the event approach. But of course, using the event approach is basically the way to go. If you want things to happen right away, you want real-time type of information to be processed, and you want the results right away. And that's when you use events. Now, then let's take a look then into event messaging, the semantics, and the patterns. So I already brought up like event-driven type of messaging. Essentially, too, the semantics is basically we call it also like streaming. And a lot of times, too, we also call this pattern pub-sub. And notice that pub-sub is an architectural pattern. It doesn't dictate how you implement it. And so it can be different ways of implementing it. But the general idea is this. You have publishing clients that sends the data. So again, those will be the producer. They publish the messages, and they don't deal with the actual sending. The sending is up to the broker. Basically, the broker is like a middleman, middle person, an agent in the middle. It's a serverless process very often in today's cloud-native world. So the broker is the one that will be delivering the messages. And delivering to who? So basically, the clients, right, that are interested in receiving the data, they will have to subscribe to the messages. And they subscribe through what is called, like, the messages are labeled as a topic, for example, in the Pulsar, and that's what it uses, or Kafka is also calling a topic. So that's kind of provide the channel as to how the broker can then deliver the messages. So that's PubSub. And then another semantics that we also have been hearing is a message queuing way of doing things. It's much like message-driven messages. They are point-to-point. It's also a form of asynchronous service-to-service communication. That's very often used in serverless and microservices architecture. That's also kind of decouple out the sender and the receiver. The difference is that in message queuing is that you queue up your messages, and once the messages get picked up by the subscriber, then it will be removed from your queue and removed from your system. As opposed to doing PubSub, very often too, the messages will still be kept until perhaps if it's being acknowledged, then they will be removed from the system. It all depends on the how the system's implemented too. So again, these are PubSub and then message queuing. And now then let's take a look then into event streaming. So event streaming is not the same as event messaging. Just now I talked about the messaging kind of semantics, all that. Event streaming is basically a step beyond just the messaging part. It basically provides the solutions to solve higher level kind of problems. And so what's driving this change? Essentially too, again, about real-time data. So you use this event-driven approach to basically achieve like real-time data that comes in. You can ingest data and analyze it right away and produce the results that your customers would need. Your systems can service all of your customers, the users of your system. So the real-time aspect that's what it enables it to do it. And then there's also, for example, in today's world, there's artificial intelligence and machine learning type of data pipelines. Think of the fact that in AI and ML system, you are constantly updating the model as the data comes in. So the turnaround time have to be really, really fast. You have to, as soon as the data comes in, you have to analyze it and then basically produce, through your algorithms, you keep updating your data model and then you deploy it right away too. So as you can see, we rely on this very, very efficient like event streaming type of systems to provide us the data, provide you with like high rate of ingestion of data, and then you can respond real quick with a low latency kind of effect. And then another kind of advantage of using event streaming is basically helps you to scale your systems real well. In a PubSub type of systems, especially, or even like message queuing, you can actually scale up your data as they comes in, and you can have tens of millions of data being ingested into your system, and you can kind of grow and shrink as easily too. So it's helping you with the scalability kind of aspect of your processing of your data. And an example would be like Internet of Things. For example, you can have a field and you can have many devices that are in the field collecting, for example, temperature data, some kind of sensor. Temperature keeps changing, so you're sending all the data in streams into your server, for example. So you can employ an event streaming type of systems to kind of help to ingest all of these data, and then they can be kind of throttled. All of the data can be kind of managed in a very orderly fashion as well. So those are the key. And so again, why event streaming? So basically, you allow your system to watch for events with the system or the application. And then essentially, too, you don't actually have to receive the messages unless you're interested in that particular topics. And you can subscribe to topics to see certain event types. And again, with real time, you can make decisions on the data in real time right away and not after the event. And again, it can help you to ingest high frequency of messages with very low latency. Now, then let me introduce to you Apache Pulsar. What is Pulsar? Pulsar is an open source project and currently is now owned by Apache Software Foundation. And it was created by Yahoo. Yahoo, back in like the early 2010s, they already have to process so much data in all of their services. And they realized that it wasn't able to, whatever system they were using then, wasn't able to address the aspect that we have multiple installation of our cloud, all the cloud servers, the cluster. So they realized they need something better to handle, especially in processing huge amounts of data in the cloud. And that's when Pulsar was born. And they contributed the project Pulsar to ASF in 2016, and quickly it became a top-level project in 2018. Essentially, too, Pulsar is born with a cloud-native DNA. That's what I would call it, because I was being asked, is it, for example, like other streaming platform on steroids? But I call it like cloud-native DNA because it's cluster-based and it supports multi-tenancy. And the nice thing about it is that it's not very complicated to use. You can write client. We call these client programs. You can interact with the broker. Essentially, broker is like the central piece of this event streaming platform. And the client APIs are not way too complicated. Plus, you can actually be able to use your language of your choice. For example, Java is kind of more native because the whole Pulsar is written in Java. So it supports Java client, but at the same time, you can also use .NET if that's your cup of tea. You can use C# and Python and Go, and other communities contributors are also contributing. For example, like Scala, Ruby, and other languages too. Now, the strength about Pulsar is that it separates out the compute and the storage. And knowing that a distributed messaging systems, you have to handle all of the messages that comes in, the broker, everything is basically Pulsar that's kind of doing all of the heavy lifting for you. At the same time, what do you do with the tons of messages that are coming in? You have to have a ways of storing them and managing them. So Pulsar is kind of smart because it knows that, well, I don't want to deal with all of these storage. So I'm delegating this part to another library to do it, and that would be Apache Bookkeeper. So Bookkeeper is the one that manages all of the huge amounts of data, the log messages. So that's also like a very kind of powerful feature of Pulsar. And not only that, too, the messages also are guaranteed the delivery, too. It basically observes the quality of service, quality QoS 1, 2, or 0, 1, and 2. So basically, messages arrive at the Pulsar broker, and it will be delivered to its intended target, too. You can be rest assured that messages will be delivered. And then there's also the serverless functions framework called Pulsar Functions too. So essentially, you can have data that comes in, and then you want to be able to do some message transformation or remediation. So there's also a Pulsar function that allows you to do it without you having to find another library or write your own to do that type of message transformation. And also, too, there's this features, too, within Pulsar. It allows for tiered storage offloads. So whenever your messages kind of becoming kind of too long, and you can already in your queue for too long, and it actually knows, and then it will transfer it to long-term storage, too, when the data is aging out. And again, what is Pulsar? This sums up, and as you can see, there are a couple of graphs that kind of describe the rising interest in Pulsar because it's truly a cloud-native event streaming platform that kind of does, take care of a lot of things in the cloud for you. So then as a developer, you don't have to worry as much about those things like managing, right? There's dual replication and multi-tenancy, all of these things. And who else is using Pulsar? So as you can see, this is a slide that kind of highlights a few kind of major customers that Pulsar is serving in today's world. And so Pulsar is different. Let me kind of go a bit more. Couple of Pulsar component, the producer, the consumer, which I've already talked about, and then the broker is a stateless process that handles incoming messages, message dispatching, and communicating with the Pulsar, the configuration store, and then stores the messages in Bookkeeper, and also like Zookeeper that needs to be helping with holding all of the cluster metadata to it handles all of the coordination tasks between all of the Pulsar clusters. So these are kind of the 5 kind of major components in Pulsar. And also, too, Pulsar has a traditional multi-node architecture. As you can see, it can scale very easily, the horizontal scaling as well. And then also topics, too, you can, it also supports like partition topics. So in other words, traditionally, you can, your messages, your topics are serviced by one broker. But the thing is, you can have multiple brokers, and then you can partition all of your topics to be shared among different brokers. And that will help in your overall throughput of your messages, too, for delivering and all of these things. It masks all of the complexity. So again, with a system like Pulsar, is basically all of these topics rebalancing because of the nature of Pulsar. It does all of the rebalancing for you if you have to increase the number of brokers or increase the number of clusters or shrinking it and everything. So that's a very key advantage of Pulsar. And over here, too, this slide will show you, too, I wanted to highlight some of the things I already talked about, but there's also Bookie, too. So Bookie itself, Apache Bookie, is basically, it respects the right archive, like logging-based specification, and it guarantees all of your messages, your log messages, too, are, they won't be corrupted in the system. And it kind of manages all of these messages in your system accordingly really well. As you can see, it segments off all of your messages as well to different storages. And it coordinates with the Pulsar broker, too, in the overall ecosystem. Okay, so just to summarize, too, it's basically Apache Pulsar is a unified solution for PubSub for message queuing, streaming, and message mediation enrichment, too. And some of the out-of-box capabilities will include like geo-replication, multi-region support, data lake integration. A lot of work is still being done to improve and increase the capability of Pulsar as well. It's fully poised for the cloud-native world that we're living in today. Again, Pulsar has this separation between compute and storage. As you can see, the storage part is handled by a bookkeeper. So then Pulsar can then focus on worrying about the broker and delivering messages and all of these things. It helps with horizontal scaling and all of these capability. And then there's also this geo-replication feature of Pulsar too. And imagine that you have a big company, you have multiple data centers, and you need to do replication. And it basically supports different very flexible messaging replication mode and patterns, like active, or active, passive, and all of these selective message replications too. And it helps to meet like data compliance requirements across different geo regions. So that's a really powerful feature that Pulsar has. Another feature, too, that Pulsar is strong about is the multi-tenancy capability. As you can see, you can also essentially divide up all of your different, in your cluster, you want to kind of partition off or kind of divide up the different functions of where your data should be organized as. So over here is like a tree structure. You can essentially label under certain tenants. For example, in your company, you can have marketing department being one tenant itself, and then the product team also has its own data. So this multi-tenancy capability is very helpful, especially in a cloud-native type of environment. Another feature, too, this actually I want to highlight is about the message processing model. Basically, you can, on the subscriber side, you can have exclusive subscription, and this actually turns Pulsar into a message queuing capability because you have dedicated consumer will be receiving messages from the producer. So you can have that dedicated one, much like functions like a one-to-one message queuing capability. And then there's also failover. You can basically mention like two consumers in your subscription is the failover one. So if the primary one goes away, then the secondary consumer will step in to receive messages. And then there's also shared mode too for subscription. Basically, that helps too in a cloud-native environment in which you can support multiple consumers for the same subscription. Now, if you want message ordering as they come in and be delivered, you can basically use a key shared mode too. So it's very, very flexible in terms of message processing model. Okay, so just a couple more information about Pulsar, and I want to talk about first the data pipeline. So basically about Pulsar function, think of this, right? We're doing event streaming, the data pipeline. Data comes in is like a faucet and going through different pipes. And then eventually, too, it reaches this point in which this is where Pulsar is. Pulsar will be the one that massage or doing all the transformation as needed, you can leverage on Pulsar function to help you to transform the data. When it is all done, then you output the data to a sink. And that's kind of essentially how it works. You can build up your data pipeline. You can have different data pipelines connecting with one another. You can write your data, that transformation in different languages, although currently it's primarily Java at this point, but there are already supporting like Python. Actually, Python also, I think it's already in the works. And then there are also other languages being supported by Pulsar function as well. So again, this is a picture that describes Pulsar functions, and essentially it allows for complex streaming processing, very lightweight, and is inspired by AWS, Lambda, and Google Functions. And and again, the main language is Java, Python, and Go. And there's also Pulsar schema. As you know, when we do messaging, we want to make sure that messages get serialized and deserialized properly. So if you don't want to do that for the data transfer part, you can rely on Pulsar schema. As you can see, it supports all kinds of schema types: primitive, key-value pair, Avro schema, JSON, and protobuf. And it also helps you if your data keeps changing. You can also leverage on it to kind of version all of your different data schema too as it changes over time. And so it's kind of a very convenient way of managing your data without worrying about serializing and deserializing yourself. And then there's also Pulsar I/O. So basically, you can build your own connectors too. So if you have a source and then you go through Pulsar, you want to output to a sink. Currently, we support Kafka Sync and RabbitMQ Sync, and also others too, many others. Elasticsearch, for example, different JDBC sync for different Postgres, for example. But you can write your own sync too if it isn't already there, and you can basically use Pulsar I/O, the library, to help you to do that too. And this is a bit of information for you if you're interested in the DataStax flavors of Pulsar. So we have Astra Streaming, which is our managed Pulsar platform. And then there's also a $25 credit too if you want to play around with it for every month too without giving your credit card. And then we also have Luna Streaming, which actually you deploy your own and using Helm chart. And then you can also choose to pay for enterprise support too if you like. Or if you want to go all open source, it is also there for you. So let's now take a quick look at how you can use Pulsar using the DataStax Astra Streaming platform. It's actually very easy. So let's get into it. Okay, so here you can sign in with your Google account, for example, or you can actually, in my case, I already have it set up. But if you are new to it, all you need to do is basically you don't need to give your credit card, just give your email address and then your name, and then you are in. And so once you are there, as you can see, because I already have all of these things open up. But the thing is, if you're brand new to it, you basically also can create like different organization, for example, to do your work. Now, if you're interested in DataStax, our Cassandra Astra DB platform, it's also here too. You can use it too to do whatever you need to. And it's everything, is free for like $25 per month, so which is great. So let's take a look for Pulsar. If you want to create a stream, all you need to do is create stream. And then, as you can see, you can quickly give your tenant name. And let's say over here, we'll say StarTree. We'll call it the StarTree tenant. And then I can pick for example, a Google Cloud. And then here is US. Actually, there's no US West, but we'll say US Central. And then as you can also then take a look to see how, when you create tenant, how much it would cost. And you can tell that for $25, if you're doing your own personal project, it's actually more than enough too. So now I won't create it now, but if you click on create, it shouldn't take more than a couple minutes for you to set up your tenant. Let's go back. And so in my case, I have multiple demos. So I go to this one that I already have a topic. So as you can see, there are things going on. But as you, if you need to create something in here, you can actually, when you create a tenant, then you will immediately be brought to this tab here that's doing a quick start as to how you can actually create your topic and then write your producer and also write your consumer too. And so it's kind of very easy. And so you can take a look, and if you click on the Connect tab, it basically gives you the URLs for your broker and for your web service URL, which is your admin URL. or you can use WebSocket as well. So if you need all of the, you will actually need all of your specific your tokens for doing client connection. You can download this client conf to config file. And then if you want to, oh, by the way, if you want to take a look, right, you want to do Java, it's here. We have example of how you can do a producer and what are the Maven and Gradle definitions. Everything is here, is easy peasy. You can kind of take a look at this and kind of play around with it. And you can have Python, Golang, as you can see, all of these other languages. And the topics too, if you want to create it, you can just do an add topic. And then basically you can say persistent topic or not, or partition or not, that type. So as you can see, it's not a very complicated. Yes, so after you have taken a look into this quick demo, I'm not able to do all the stuff that you can do, and it's just so much more. So let's take a look now and to see where you can go from here, and let's keep in touch. So here are a list of all of the resources that you can look up on Pulsar, on Bookkeeper, on Zookeeper, as well as the Astra DB that I was just showing you at https and astra.datastax.com. And that's where you can sign up for our Astra DB and streaming access. And then if you want additional information on Astra streaming, Luna streaming, and also our change data capture for Astra DB, that one will be on a separate talk. You can check that out too. And then if you want to sign up for Astra DB for extra credit, $200 in credits US dollar, you can use this open source 200 coupon code and this link to sign up for additional credit. Also, we have 5 minutes about Pulsar on our YouTube channel. So this is the link that you can go, or you can search for DataStax developers on YouTube, and then you can look for our 5 minutes about Pulsar playlist. And also, I have my own Twitch stream every Wednesday at 2 p.m. normally when I'm in town and at home, Central Time. So this is the link where you can reach me. And also, I will be interacting with the audience like yourself. If you're interested to join me, share with me your stories, your developer journey, I'll be very happy to do so. And I'll be demoing a lot more things in depth. Also, please join us at the Hood, and these are Apache Pulsar neighborhood links of our meetup.com meetup group. Also, our Apache Pulsar neighborhood wiki site that you can also contribute to. With that, I want to thank you again. Thank you again to StarTree, to the Real-Time Analytics Summit for giving me this opportunity to talk about event streaming and Pulsar. And I wish you all well, and please keep in touch. Join me on my Discord server as well, which is just right below on the screen here. Thank you.